Hello and welcome to a new video about deep reinforcement learning. In the last video, you have learned how to train an agent with certain strategies by introducing penalties or certain rewards and by doing curriculum learning. So to learn step by step to go from the easiest to the hardest environment so that the agent can learn everything that is necessary to master all of the difficulties. In today's video, we want to analyze these results and compare it with the benchmark, which we have trained 2 or 3 videos ago. So let's see how good our strategy worked out compared to just training an agent for a long time. So let's have a look. And if you have not watched the previous video yet, then you can find it here in the info box. So let's take a look at the results. We begin again with the hardest level that the agent has. So a fast moving big target, which gives a lot of reward, but which also can fall from the platform. Here the agent tries to catch the big target, but in case the target falls from the platform, the agent stops and goes to the small target to reset the game. This is exactly what we have trained, so we gave the agent always a strong penalty when it falls from the platform, so it learned to not only hunt behind the large target, but also think about being secure on the platform. This kind of strategy is helpful in real-world applications. When you think about autonomous driving cars or humanoid robots, they should interact with the environment, but they should not create damage on something else or on themselves. So having a strategy that is secure and safe is really the key for these kind of applications. So if you take a look at the results, we see that the agent reaches a reward of 126 in the hardest environment. During all the time, he was only falling once from the platform and tried to catch the big target before then going to the alternative small target. When we have the benchmark and the strategy side by side, you see a clear difference. The benchmark really just tries to hunt behind the big target no matter what. But in the strategy, it's more secure and more safe without really falling from the platform. This comes even more visual when we take a look at the numbers. So the rewards in both scenarios are very similar, but the falling events during the benchmark run is 11 times higher than during our new strategy, which we just have implemented. The benchmark reaches more often the big target, but also falls way more often from the platform. So let's switch to the medium difficulty. Here the big target is not very fast, so approximately in the velocity scale of the agent itself. And the agent really tries to get the big target. In some cases it looks a bit strange, but the main goal of the agent is to be secure on the platform and not fall down. So here it was good, but in some other cases we might wish that the agent would be a bit more fast. And here there will be one situation which I don't want to hide from you. It comes now. So here in this situation, the ball is getting a very fast speed by being spawned on the small target. And this high velocity of the big target triggers something in the brain of the agent that makes it running behind and falling from the platform in the end. So here the training would have needed more variation to overcome these issues. So let's take a look at the results of our agent. We can compare it with the hardest environment, but we can also compare it directly with the benchmark, where we see that our strategy again does not fall down from the platform very often, but the benchmark catches the big target way more often than our strategy is doing. This is because the benchmark is not afraid of falling, so it can hunt the big target till the edge of the board without stopping too early. If you have an idea how we can implement a strategy that our agent will catch also these events, write it down in the comments. And we continue now with the simple environment. If you remember from the last video, in the simple environment, the benchmark performed very badly and didn't reach the big target at all. This we now more or less overcome with our strategy here, because our strategy had during our curriculum learning the chance to have all these variation, so also the not moving target ball, and it has learned from this and is able to reach the target even though it is standing. Unfortunately, this does not work in all of the cases. And this has something to do with the replay buffer, which we introduced in the second last video, I think. When the replay buffer is filled with too many new episodes, variation or learnings from the past might get lost. And if this learning gets lost, the agent does not know how to react in a situation. It's similar like with you unlearning a language when not using it, or unlearning some other skills that you knew in your childhood and now you can not do it anymore. It's similar with the deep reinforcement learning agent when the replay buffer overrides old episodes with new episodes. So overrides old skills with new skills. So to keep it short, the agent also fails in the simple environment, but after 70 counts and not only 7. So let's stop here and let's take a final look at our results. We compare the benchmark with the strategy in the simple, medium and hard environment. And here you get an overview about the rewards, how often they fall, how often the big and the small targets are catched. But I would say you can take a look at this alone and make your own conclusions. What you can do as a homework is thinking about how to get a strategy even better or even faster without being afraid of the borders of the platform. If you have ideas, write it down in the comments. I would be happy to discuss it with you. So, congratulations! We have just finished the first part of our video tutorial series on deep reinforcement learning with Unity, where we have learned how to build three-dimensional environments in Unity, how to scale up the training to make everything faster, how to make the worlds colorful and how to train it with TensorBoard. We have learned how to read the documentation to build a good configuration file, and we have learned so many more things. So now it's up to you. How do we want to continue? With Unity and reinforcement learning, also in complex environment, or with multiplayers, or with visual input? Or should we more go to the direction of robotic simulations with Gazebo and ROS? Or to collaborative robots with hardware? Now it's up to you. Write it down in the comments and I will try to adjust my YouTube tutorials based on your wishes. I'm curious what you're curious about and see you in the next video. Thank you for watching. And if you want to support me on this journey, please consider to like and subscribe. And if you want to support me a bit more, you can do this on these platforms. Thanks a lot and see you next time.